This is Group 8, and our project is building an improved book recommender system using machine learning. The goal of the project is building a book recommendation system that transforms data into potential matches for users. The two main types of recommender systems are content-based filtering, which recommends books based on similarity, and collaborative filtering, which recommends books based on existing user ratings. The project's goal is to determine meaningful correlation between a book's cover image and other features of the book. Using this information, we hope to build on and improve current recommendation systems. By analyzing the book's cover image, we hope to determine possible informative correlations between the book's cover image and the following features: rating, genre, and year of publication. Using this information, we are going to build our own recommendation systems. A content-based recommender using book-related features, a user-based recommender using user-related features, and an image-based recommender using the book's cover image.
The dataset were collected with Book Cross user rating from Kaggle. This contains more than 200K information with different users and books. In the user rating, age, location of user were provided. Contents provide title, author, cover image, publisher, year of publication, category, and summary. The pre-processing was completed before going into the computational analysis, including the removing invalid and blank data. Also, one-hot encoding was used for vectorizing the items, which will be described in the later slides, and the image was resized based on the convolutional neural network that we'll be using.
For our user-based analysis, we clustered users based on the features country, rating, and age. Because we have mixed numeric and categorical data, we pre-processed the data in two ways. First, we converted the countries into continents and used one-hot encoding, and an example of the resulting dataset is shown. We then used k-means and GMM to cluster similar users. The second way is with Gower distance for clustering. When looking at the Lawson-Davies-Bolden index, we see that a good number of clusters is 4. For our item-based analysis, we started by clustering users like in our user-based analysis, using age, country, and average rating. We clustered users with k-means, GMM, and dbScan. After clustering the users, we created a pivot table of each user's ratings and used this table to calculate the average rating of each book for each of the clusters. Finally, we used pairwise cosine similarity to find books that are similar to our input book. Here is an example of 5 recommendations generated through item-based analysis. For our analysis using book features, we used the book title, author, category, and publisher as features. We combined them into one column and created a document term matrix of the unique word counts for each book based on this column. We then used k-means, GMM, and dbScan to cluster together similar books. Finally, we randomly select 5 books from the same cluster as an input book. Here are example recommendations for the book The Testament, produced by the 3 clustering methods. For our analysis using book summaries, we created a document term matrix of the unique word counts for each book summary, and an example of this matrix is shown here. We used k-means, GMM, and dbScan to cluster together similar books based on summaries. We then randomly select 5 books from the same cluster as the input book. Here are example recommendations for a Harry Potter book generated by the 3 clustering methods.
For the image processing, first we dropped out the parts that does not match the standard RGB format, which end up with width, height, and 3 RGB layers. After that, the duplicated images were dropped, only allowing unique images to be presented in the dataset. It returned roughly 170K images total, randomly selected based on the usage. The width and height of the images were selected based on the NN to run, 32 times 32 for the custom nets, while bigger size for the transfer learnings.
We tried to predict the category of a book from 10 possible categories using the image of the book's cover. First, we found the 10 most popular categories and the number of books in each one. We decided to randomly sample 1,400 of each of the categories for a total of 14,000 books. We then resized the image of each book cover to be 32 by 32. Because we are working with images, we decided to use a custom convolutional neural net. We were only able to achieve a test accuracy of 26%, which is less than we hoped. However, we are still satisfied with this result because the task of predicting a book's category using its cover is quite difficult. In addition, we did not have a very large dataset with only 1,400 books in each category, and the quality of the images was not very high since we resized them to be 32 by 32. With a larger dataset and higher resolution images, it is possible that we could have achieved a higher test accuracy. If we look at the confusion matrix, our model often confuses juvenile fiction for juvenile nonfiction and vice versa, which makes sense because they are arguably the two most similar categories. It also has a hard time properly classifying social science books, which may be because social science has many similarities with several of the other categories.
The goal of the book rating prediction model is to predict the average user-given rating for a book using the book's cover image. Initially, the model used in the category prediction process was also used to predict ratings. When performing some preliminary tests on a small sample dataset, we noticed that the model was quickly overfitting. To prevent the model from overfitting, we added an extra dropout layer and FC4 layer to our CNN's architecture. We also performed some hyperparameter tuning. We decreased the batch size to 32 and increased the learning rate to 0.01. Using the new tuned convolutional neural network, we were able to obtain a test loss of 2.315 and a test accuracy of 12.3%. Despite the test accuracy being very low, the model is not impractical or ineffective. This is because it is still able to classify book ratings more accurately than the uniform random probability. The outcome is as expected, as book ratings are often associated with the contents of the book, not its cover image.
To predict the year of publication from the book cover image, we firstly separate all the images into 3 different categories. Then we randomly selected 1,200 images from each category and split them into 3 different sets: training, validation, and test set. All the images have been reshaped to 224 x 224 pixels in this section and set the batch size as 32, epochs at 20, and learning rate as 0.0001. We use the categorical cross-entropy as loss function and adaptive moment estimation as optimizer. We trained 5 different convolutional neural network models. We firstly trained our custom CNN, containing 6 convolutional layers and 3 fully connected layers. We then used 2 pre-trained models, VGG16 and ResNet50, and fine-tuned them with slight modification. Here shows the comparison of the performance of these 5 models. Among all these models trained in this study, the ResNet50 model with all the trainable layers obtained the highest training accuracy, while its validation and test set are around 50%, probably indicating overfitting. The modified VGG16 model with first 10 frozen layers performed best for the test set. The precision is 53%, recall 52%, and F1 score 50%. That's possibly because VGG16 is a well pre-trained model for image classification, and our modified VGG16 has the most trainable parameters among all these models explored in this study. Overall, the accuracy of all these 5 models is not high enough, possibly because the book cover images do not contain much information about the year of publication.
As a conclusion, so far we developed a book recommender that uses the different machine learning algorithms. For the unsupervised learning, we developed 3 different recommendations based on the feature selection, item, user, and content-based. Generally, k-means were effective for each of the categories, while content-based filtering showed effectiveness on the GMM as well. In terms of the supervised, the convolutional neural network was used to analyze the book cover image, reinforcing the bigger correlation on years of publication and category over the user rating to the book cover image.